Alright, hi everyone. So for this video is going to be the first video that we are going to talk about networks and decision mathematics. Okay, so I hope that you still be able to recall, the relationship between like the two topics that you have learned in Unit 3 and 4. So bivariate data analysis is related to 4.1 time series data analysis. So the sequences that you are learning is related to the financial mathematics that we learned in the last topic. And also 3.3, we talk about graphs and networks. So in this chapter, we are going to talk about networks and decision mathematics. Okay, so I would say that this topic is rather I wouldn't say it's easy, but you will be learning a lot of new things, but it wouldn't be like that. The content itself is not as extensive as the previous topic. So that's why do make sure that you are able to understand all the new knowledge that you are learning in this topic, because it's going to be a good chance for you to score in the test as well. Okay, so I would say that this is like the so-called the second easiest topic that you should score other than graphs and networks. Okay, so do make sure that you understand every single thing that we are going through. Okay, so I'm going to split the lesson to two parts covering the minimum spanning tree. So for this first video, we are going to talk about what a tree is and also what a minimum spanning tree is. Okay, and then after that, we also talk about how to solve minimum spanning tree problem by using Prim's algorithm and also by using Kruskal algorithm. Okay, so these are the few things that we'll be covering in the first video. Then after that, in the second video, we'll talk about distance table. Okay, then we will be looking at the content now. Okay, so before we look at the learning outcome, we'll just look at an overview for the top, for this entire topic first. Okay, so in topic 3.3, we learn about the basic of graph theory. Okay, so if you remember, we talk about what an edge is, what a vertex is, then multiple edges, loop. Then we also talk about what a planar graph is, the different type of walks, the different type of connected graph, and also one of the application that we learned in topic 3.3 is how to find the shortest path. Okay, so for in this topic wise, we are going to delve deeper into graph theory, but then we will be focusing in 4 different type of application. Okay, so the first one will be covering in today's lesson, which we talk about minimum spanning tree. Okay, minimum spanning tree. Okay, the second one we will be talking about this next week, which we talk about maximum flow. So basically, we will discuss one of the application in each of the week. So that's why you should be able to foresee that you will be having your test like after 4 weeks. Okay, so minimum spanning tree this week, maximum flow next week, then next week, we are going to talk about project network. Okay, and for the last week, we have allocation problem. Okay, so once we have finished the allocation problem, then the following week will be the week that we'll be doing the test. Okay, and that's basically the week before your Chinese New Year. So that's why we can finish the entire thing before you move on, to celebrate it. Okay, so for all these 4 applications, you will be having their own algorithm that you will need to learn. Okay, so an algorithm is basically a precisely defined procedure. So that is a set of steps that you need to follow to solve a certain problem. Okay, so each of these application will have its own algorithm. So that's why it's important for you to understand what are the situation that you have and what's the problem that you want to solve. So that's why you will be able to understand and know how to differentiate the situation and make sure that you are using the right algorithm. Okay, which means if you are solving minimum spanning tree, then you cannot use the algorithm for maximum flow. So if let's say you are solving maximum flow, then you can't use the algorithm for project network. So you should be able to differentiate the meaning or the definition for each of the problems so that you are able to apply the correct thing. Okay, but no worries, it's actually not very hard to differentiate. The thing is to make sure that you understand and be familiarized with all the algorithm, then you will be fine. Okay, so for today's lessons, why we are going to look at minimum spanning tree. So the first one is to understand what a tree and the spanning tree is. Then after that, we are going to look at Prim's algorithm and also Kruskal. So Prim's algorithm is the one that is recommended in the syllabus, but then I will teach you one extra one, which is Kruskal, because I personally feel like Kruskal is easier. But then when you are, I mean, just based on your working itself, then we wouldn't be able to know whether or not you are using Prim's or algorithm. So it's good that you know how to do both, so that in the exams wise, you can carry out both and to double check your answer. Okay. So 4.3.3 is basically to solve the problem. Okay, so we are going to look at what a tree and what a spanning tree is first. Okay, so first part, what a tree is. So a tree is basically a connected graph. Okay, so a connected graph meaning that all the graph, you should be able to find a way to reach any vertex, right? So connected graph, the definition, there is a path between any vertices that you are looking at. Okay, so which means that there's no isolated vertex, or the graph didn't like split into two distinct groups that you are not able to go to the other side. Okay, so that's why this is a connected graph, because no matter which vertex that you are looking at, then you should be able to find a way to reach the other one. So a tree is a connected graph, and then one of the additional thing is, except a connected graph, you also must ensure that there's no cycle in the graph itself. Okay, I give you an example. So which means that if let's say this is one more edge here, and this is no longer a tree because you create a cycle over here. Is that okay? So which means that, for example, if let's say we have one more edge over here. So which means that this is no longer a tree as well, because you can see that this create a cycle. Okay, so the idea is that you wouldn't be able to find a cycle in a tree. So I hope that's clear what a tree is. Okay, so after we understand what a tree is, then now what a spanning tree is. So a tree, we are referring to a graph, but a spanning tree, we are referring to a subgraph. So a spanning tree is a subgraph of a connected graph that connects all the vertices. Okay, so for example, you can see that this is a graph. Okay, so basically the one that without the dotted line is, the dotted line that you are seeing here is a spanning tree. Okay, so which means that you can see that, let me highlight that. Okay, so you can see this is a subgraph, and am I right? So I didn't add on any new edges or new vertices, and this is part of a graph, right? So that's why this is a subgraph. Okay, and you realize that there's no cycle that created for this subgraph. So that's why this is called a spanning tree. Is that okay? Right? So now, one more time. So which means that, oh, sorry, I should explain the part that involve all vertices. So you can see that my subgraph here involve all the vertices. So like 1, 2, 3, 4, 5, 6. Okay, so the subgraph actually involve all the vertices, and you didn't create any cycle, and this is called a spanning tree. So of course, other than the dotted line that's given, so I can also have my spanning tree like this, for example. I can also have it like this, like this, like this, like this, like this. Okay, so this is also a spanning tree because I involve all the vertices, and then I didn't create any cycle, like there's no cycle, right, for my subgraph. So that's why this is also a spanning tree. Okay, so which means for a graph, you can create like all the different kind of spanning tree that you want to create, as long as it's a subgraph, and as long as it connects all the vertices, then it's called a spanning tree. Okay, so before we move on the next part about minimum spanning tree, we are just going to go through the example. Okay, so if you can, I would like you to pause the video a while, then just think about it first before we move on. Okay, so you should have just finished it. Then after that, we move on to the answer. Okay, so for the first one, so as you can see that this is like in the graph itself, you should be able to find a cycle. Okay, so that's why this is not a tree. Okay, so no, because there is a cycle. Yeah, and I just want to clarify, it doesn't mean that your entire graph must be a cycle, which means that if let's say there's edge here, okay, if let's say there's an edge here, then this is still considered not a tree because you are able to find a cycle. So as long as there's part of your graph that can build a cycle, then you know that it's not a tree. Okay, it's not that your entire graph has to be a cycle. Okay, then after that for part B, okay, so for this one, you can see that in this case, you don't have any cycle, right? And the graph is connected. So that's why yes, it's a tree. Okay, part C. Okay, so for this type of graph, then there's no cycle, but you realize that the graph, they are not connected. Okay, which means that, for example, you won't be able to find a path between C and H, right? So, but then for connected graph, you must make sure that there's a path between any pair of vertices. So that's why the answer here is no, okay, because it is not connected. Okay, so that's basically for question 1. I think it's quite straightforward. Okay, so for part 2, so the following graph outlines the current water system between garden beds. So the plumbers have noticed that the water is being wasted as there are too many pipes that are being used to connect the garden beds. So question A asks us to draw a spanning tree for this graph. Okay, so there can be a lot of different answers. It just depends on, you know, which way that you would like to draw it. Okay, so so maybe one thing that you can try to do is you can try to label all your vertices first. Okay, because you know that a spanning tree must involve all the vertices, right? Okay, so by doing this, then you will ensure that you didn't left out any of the vertices. Okay, so for example, I can draw like this. Okay, so as I have connected this, then I must make sure that I cannot draw this anymore because this will create a cycle, right? Okay, then you can do anywhere. It's actually up to you, like how you want to, yeah, but make sure that it's supposed to be a subgraph, which means if let's say there's no CE here, then I cannot create an CE here. Okay, so for example, like this. Okay, then this is a spanning tree because I already involve all the vertices and then there's no cycle created here. Okay, so after we finish this part, then now you can label. So like A, B, C, D, F, E, G, H. Okay, so your answer can be all different than mine. That's all fine. It's just make sure that you are drawing a minimum spanning tree. So for example, I can also have a shape like this. Go down, C, F. Yeah, okay, so this could be the idea as well. Okay, so I didn't create any cycle and I have already made sure that I involve all the vertices. Okay, which in this case, then I have 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's up to your answer. Okay, so but you just make sure that you have involved all the vertices and also make sure that there's no cycle form. Okay, so if let's say I'm doing it based on my answer here, then which means the edges that I remove is BD. And then I also remove EG, I also remove FH, and I remove AE. Okay, so you answer this question based on your own drawing. Okay, so that is question 2. Okay, so I hope that by now is clear. Okay, so just add on a bit of explanation. So the idea when they talk about there are too many pipes being used, then which means that, for example, if let's say the water coming from E then I just need to make sure that I am able to find out a way to reach any place that I want. So which means that if let's say the water can reach B via here, then I actually don't need this one. I just make sure that the water can reach D sufficient. So that's why I don't need AC as well. Okay, so that's the idea for why we are using this spanning tree to answer this kind of question. Okay, so that's the first part, and we have covered the first learning outcome, which what a tree and what a spanning tree is. Okay, then now we are going to talk about minimum spanning tree. All right, so for minimum spanning tree, we'll be looking at this situation and try to understand it from this simple example. Then from there, you should be able to differentiate, you know, the idea between minimum spanning tree and also shortest path. Okay, so suppose that for this question, you are given a network here, and there are routes that exist between 9 of the farms A to I, and the weights here indicate the distance in kilometer. So the question said that the water authority wishes to connect all the farm to the main water supply by laying water pipes alongside the existing road. Okay, so which means the idea is that if let's say today we need to find out the most effective way to solve this question, do you think we can use shortest route? Okay, so which means that in the shortest route, we learn, like, for example, okay, I find out that maybe this is the shortest route for me to go through that. Okay, but you realize that the idea for shortest route is that you are talking about what is the shortest distance for you to be able to reach one place from one place. So shortest route doesn't require us to go through every vertex. Am I right? So for example, in this case, if I want to go to I via the shortest route from A, then which means if let's say this is the way that I'm taking, then F and H doesn't need to be included. Okay, but for now, if we are talking about you want to find out the shortest way that you can lay the water pipes alongside of the road and then still connect all the farms together, then we can't use shortest route. Does that make sense? Okay, I hope that you can understand the idea here, where we are not talking about the shortest distance between two vertex. We are talking about what is the way that we are able to find out a way that we are able to connect each of the vertex all together via a shortest distance. Okay, so in this case, we need a system that includes all the farm, okay, which has no unnecessary connection. That which means that, you know, the road that need a longer distance, then we are able to eliminate that, for example. Okay, so which has no unnecessary connection. So what we need here is basically called as the minimum spanning tree. So what we need here is basically called as a minimum spanning tree. So which means that we are able to find a way to create a subgraph of the graph that they are connected all the vertices together, and at the same time there's no cycle. So the idea for no cycle is that, okay, for example, right, if let's say I already make sure that the road is placed like this. Okay, I'm just doing an example. Okay, for example, this is my minimum spanning tree. Then which means that in this case, right, I do not want to involve BE because water can now flow to B and E already. So which means the 22 here is like the unnecessary road. So it's the same thing here. If let's say water can flow to E and G and H now already, then I wouldn't want to add on EG or EH because this is unnecessary. Okay, so that's what we meant by minimum, the spanning tree, but then giving us the minimum weights. Okay, so in order for us to do this, we need to learn an algorithm. Okay, so the minimum spanning tree is the spanning tree with the minimum total weights, like what I have explained just now. Okay, so in our course, we will be learning two algorithms. We will start from the first one, which is the Prim's algorithm. And understand Prim's algorithm is important because that's the one that the syllabus asks us to learn. And also, when we are learning distance table, then Prim's algorithm is the only way that we can use. So when I say Kruskal algorithm is easier, it means that in the diagram itself, then you can use Kruskal algorithm, or for just the idea for checking your answer. Okay, but then Prim's algorithm is still important in such a way where, you know, that's what the syllabus asks for. And also when we learn distance table in the next lesson, then you have to use Prim's algorithm. Okay, so it will be good that if let's say now you can grab a highlighter with you, and I think that will make it easier for your, for your notes later. Okay, so if you can, then you can grab a highlight with you. Okay, or you make sure that you have a pencil also, then you can just shade. Okay, so we are going to start from the first one, which is Prim's algorithm. So Prim's algorithm is also known as the method of choosing vertices. Okay, so the idea for the algorithm is that you can choose anywhere to start, then you build up the minimum spanning tree by connecting the neighbor with the minimum weights until all the vertices are included and no cycle is introduced. So you'll keep on doing this until you get the answer. So no worries, we'll go through it step by step so that you are able to have an idea what you are doing it. Then when we move on, then it's easier for you as well. Okay. So step 1, you can choose any vertex within the network as a starting point. So no matter you use D, you use B, you use I, you use H, doesn't matter, okay? So the idea is that because at the end of the day, you need to connect all vertices together. So no matter where you start, at the end of the day, you will be still getting the same answer. Okay, so in my case here, then for the first time, we are just going to start from A. Okay, but later we are going to try for the rest as well. Okay, so let's say I start from A. Okay, so with your highlighter, then you can start A. Okay, so you can highlight A first. So this is the idea for choosing vertices. So as you choose A, then you ask yourself, where is the neighbor for A? Okay, so in this case, then what you are having here is that B and C is the adjacent vertices. Am I right? So B is adjacent to A, C is adjacent to A. I hope that you still remember the idea for adjacent. So which means the vertex that connects with the other vertex by only one edge. So B and C, which is so-called the neighbor for A. Okay, so now you need to look at both B and C and ask yourself, which is the neighbor that is nearer to you. So you go to that neighbor. Okay, so it takes 11 to go to B and takes 12 to go to C. So that's why your nearest neighbor is B. So we choose B. So you highlight B, then you highlight the edge. Is that okay? If you are using highlighter, then you do that. Okay, so now for step 3, so which means that now we have already choose A and B just now, right? So you will need to keep on highlighting because I split it to all the different steps. So next time when you are referring to the book, then you will be able to understand it better. Okay. So, but then in the reality, you will do all these steps in just one diagram. They wouldn't give you like so many diagrams and ask you to do one by one. Okay, so this is the picture that we have gotten it from step 2 just now. Okay, so now what happened is that among all the adjacent vertices, so now you have 2 vertices to look at. So which means you need to look at both A and B. So the neighbor for A, you have C, and the neighbor for B, you have E. So you need to look at all the vertices that you have already highlighted and find out all their neighbor. Okay, so for the neighbor for A, you have C. The neighbor for B, you have C and E, right? So that's why you need to look at 12, 7, and also 22. Okay, so in this case, then the nearest neighbor to go with is going to be 7 go to C. So that's why we choose C and then we take 7. Is that okay? So of course, C, you can go via A as well, but then 12 is further. So that's why the neighbor from C, the neighbor for C, the nearest is going to be the B here. So that's why we take 7. Is that okay? Right? So as you choose it, then you must make sure that there's always no cycle is introduced. Okay, now the same thing, we go on to step 4. Okay, so make sure you highlight the exactly same thing as your step 3 first. Okay, so this is what we have covered just now. Okay, so now same thing. Now we have 3 vertices that is highlighted. So we have A, B, and C. So you need to look at all the neighbor for A, B, and C. So the neighbor for A, we have C. The neighbor for B, we have E. The neighbor for C, we have D and F. Okay, so in this case, then we are finding the vertex that is the nearest as well. Okay, so the next nearest that we are having is actually A to C. But you realize that if let's say you were to involve this, right, then you are going to create a cycle here. So that's why we are not going to pick this edge. Okay. So now then, if let's say we cannot pick this edge, then we are going to find out the next one that is nearer. So you can see among 22, 16, and 21, 16 is the nearest, right? So we choose to go to B and then pick 16. Okay, so that's the idea here. Then move on for step 5. So same thing, we draw the same step as before. And for now, we already have 4 vertices connected, which is A, B, C, and D. So now we need to look at the neighbor for all the 4 vertices here. So just now we already said that to make sure that we don't create a cycle, then AC wouldn't be able to use, right? Then which means for now, you can just look at all the other. So that's E from B, E from donkey, G for D, F for C and D. So which means that we are looking at here, 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 and here. So the one that gives us the nearest neighbor supposed to be F, and then is 7 here. Okay, so that's why the same thing for step 6, we are going to do the exactly same thing that we have involved just now in the previous step. Okay, so which means by now we have already connected all the 5 vertices together. Okay, so you can see that, for example, you are not going to connect C and F together because this will create a cycle here. So that's why the next neighbor that you are looking at for all the vertices here include E, so which is 22 here, 8 here, or 12 to G, or 8 to G. So that's why among all the vertices here, then which means that the next one that you are having is 8, right? So if let's say there are more than one vertex that give you shortest distance, then you will pick either first. Okay, so regardless you are going for E or you are going for G, they are all fine. But let's say we go for E first. Okay, then now the same thing for step 7. So we are going to copy the exactly same thing that we have in the step 6. Okay, so these are the vertices that we have connected so far. Okay, so by now then these are all the vertex that we have already connected. Okay, so we do the same thing now, then we are looking at the entire, the other vertices. So which means, for example, you must make sure that you need to connect to G, I, and H also. Okay, so we'll be doing everything on this last diagram because it's the because it's going to be the same thing repeated. Okay, so which means the same thing, either we can go to H via 10 here, we can go to G via 10 here, go to G via 12, or go to G via 8. Okay, so that's why for this case, then you know that the shortest one supposed to be the 8 to G. Okay, then the same thing, we left with H and I, right? So you know that you don't need to look at other edges anymore because there are only 2 vertex that you are not reaching yet. So as long as you are able to connect to that vertex, then you finish what you need to do. Okay, so you have 10 go to H, 9 go to GH, and also 7 go to I. So the shortest one is to go to I, take the 7. Then after that, the next one is either EH, GH, or IH, and the shortest one is GH, so that's why we take GH. Okay, so once you have finished your work, right, then something that you should check is that whether or not there's a cycle include or not. So when you look at this answer, there's no cycle. Then the other thing that you need to check is the number of edges that involve, right, will be 1 exactly lesser than the number of vertices that you need to include. Okay, because you can imagine, for example, if let's say I have two vertex, then the minimum will be 1. So if let's say I have 3 vertex, then the minimum will be 2 to make sure that it's connected, right? So that's why the number of edges will be 1 less than the number of vertices that involve. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you got 9 vertices. And then you realize that you should have 8 edges. So 1, 2, 3, 4, 5, 6, 7, 8. So if you have more than 8, then which means that you have unnecessary edges. Okay, so that's the idea for this question. So determine the minimum distance that needed to connect the farms together. Then we add all the weights together. Okay, so basically this, what we find here is basically called as the minimum spanning tree. So this is the shortest way that you can allow the farm to be connected. Okay, so we have 11 plus 7 plus 16 plus 8 plus 7 plus 8 plus 9 plus 7. Okay, so you can use your calculator or yeah. So one more thing to remind you, for this chapter, you should always you should always practice your mental calculation because for this chapter, a lot of question will be coming out in calculator free. Okay, so which means, for example, for this question, then you should be able to know how to use mental calculation to do that. So try to think about how to make up like 5 or 10 to make things easier. So for example, you can think about it like this. So 11 plus 9, you got 20, right? Then 20 plus 15, 35. 35 plus 15, you got 50. So 57 plus 16, that's where you get 73. Okay, so that's how you can do it. So 73 km. Of course, like writing the vertical calculation, that's fine as well. Okay, so that is how we use Prim's algorithm to get it. Okay, but we are going to do some extra thing, which is we are going to try to learn, also to make us to, reflect whatever that we have done just now, but then we are going to use like different starting point. Okay, so if let's say you think that you are actually quite familiar with whatever that we discussed just now, then you can pause the video and do it yourself, or else then you can follow me for one time, then after that later for you will do it one more time for yourself. Okay, so we do the same thing. Okay, so now we are going to start from D. Okay, so same thing, start from D, the nearest neighbor, either DE, DG, DF, or DC. So the nearest neighbor is supposed to be DF. Okay, so as you already chosen this, then you must make sure that as you are looking for the neighbor, you need to look at for both D and F. So which means for now, your choices will be DE, DC, DG, FC, or FG. So the shortest one, either you have DE or either you got FG. So maybe let's say we go for FG first. Okay, so the same thing as you move on, then you will be able to see that either you need to go DE, DC, FC, GE, GH, and GI. Okay, I repeat one more time. You must make sure that you look at all the vertices. So in this case, for example, you shouldn't be reminding yourself that like this is 8. So you choose the 8, then after you choose this, then you go to this, because you realize that this is actually shorter. Okay, so you must make sure that you cannot straight away choose 2 vertices that give you the shortest one, because maybe there are some, fastest route. If let's say this is 7, this is 7, this is 7, then I actually don't need this 8. Okay, so that's why you must make sure that as you choose one, then you make sure that you don't straight away go for 8, 8. You must make sure that you check all the other neighbor first. Okay, so which means that you need to look at all the neighbor for all D, F, and G. Okay, so repeat one more time. DE, DC, FC, GE, even GD you also need to look at, but GD you are not going to pick it is because of you can't create a cycle. And then GH and also GI. Okay, so among all these, the shortest one is GI, so that's why we go to I first. Okay, then the next one, same thing, DE, DC, FC, GE, GH, or IH. So among all these, then the shortest one is E, okay, which gives us 8 here. Okay, so now then you'll be looking at all the neighbor for E, D, F, G, and I. Okay, so we have E, B, D, C, F, C, E, H, and we are not going to take E, G because of this will create a cycle, and we are not going to take E, G because here create a cycle. So your choices will be still G, H, and also IH as well. Okay, so among all these, the shortest one that you are able to find from 22, 16, 21, 10, 9, and 10, then the shortest one is 9. So that's why we take here. Okay, so as you have finished up to here, then you realize that you are not, you don't need to look at this part anymore because all of the vertices here is already connected. Then you can shift to the other side of the graph already. So which means that in this case, then you should be able to look at EB, DC, and also FC. So that's why the next one that we can go to is C, because 16 is the shortest among the 3. Okay, then after that, the next one, same thing. These are the 2 that you haven't connected. So either you can go 22, 7, or 12. So that's why 7 is the shortest one. So we go for 7. So 8 is the only one is not connected. Then among 11 and 12, then definitely 11. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and you realize that your answer should be the same with what you have gotten in the previous part. Okay, so this is to show that regardless where you start, you should be able to get the same thing. Okay, so you can practice for I. Okay, if let's say you still feel like you are still a bit unsure, then you can still listen to one more time of explanation. Then later we still got time for you to do your practice. Okay, so we have I here. Okay, so neighbor 10 or 7, so that's why 7. Okay, so neighbor 10, 9. Okay, 10, 12, or 8. So 8 is the shortest. Okay, so neighbor again, 10, 9, 10, 12, 7, or 21. So shortest 7. Okay, so neighbor 10, 9, 10, 8, 16, or 21. So among all shortest is 8. Okay, so now same thing, 10, 9, 10, 22, 16, 21. So the shortest one is age, fire 9. Okay, so this part of graph is already settled. Then the same thing, like you are looking at where is the one that you want to go to, A, B, C. Okay, so EB, DC, or FC. These are the neighbor to your current spanning tree now. So that's why the nearest neighbor is C, 16. Okay, then EB, then you are not going to draw FC markers. This will create a cycle. EB, CB, okay, or CA. So the shortest is CB. Then the same thing as well. The next one, either 12 or 11. So 11 is shorter. Okay, so you should be able to get the same thing as above as well. So repeat one more time. No matter where you start, your answer should be the same. Okay, so this is for Prim's algorithm. All right, and now what I want you to do is you go to your page 116. Okay, so what you need to do here is read through the question, because of course for now when we are learning minimum spanning tree, then you know that you need to get minimum spanning tree. But there will be a situation that, you know, in the exams itself, then all the question will be all mixed together, right? Then which means you should be able to read the question and understand that you need to use minimum spanning tree to solve this question. Is that okay? So that's why I try to read through the question and understand whatever that you are doing now, and then solve the question by using Prim's algorithm. So which means only finish this part. Okay, so you should be able to get the first one. The answer is, so you just write down your entire working, like what are the distance that you need to plus together. Okay, so for the first one, you should be able to get 2110 meters. And the second one, you should be able to get 72. Okay, so I want you to pause the video and then do it now before you move on to the next one. Is that okay? So please pause it first. All right, so a very quick one for the answer. I'm going to start from W2. Okay, so the next neighbor. Okay, move on. Okay, if you're doing it correctly, then you should be able to get this answer. So when you add up, when you apologize. Okay, when you add up for all the number together, then you should be able to get the answer that I gave to you. Okay, so you just list down the entire thing, then write down the answer. Okay, so same thing for question 2. Okay, let's say I'm starting from S1. So if I have my S1 going first, okay, so as you think that you have already completed that, make sure that you double check there's no cycle. Okay, and then you must make sure that all the vertices is already connected in your spanning tree. Okay, so when you add up all the number together, then you should be able to get the answer that I gave to you. Okay, all right, so which is 72. Okay, so I hope that you are all right with this. If let's say you didn't get the answer, then you must make sure that you go and understand and see whether or not is there any part that you did it careless or anything. Okay, so feel free to just text me if you got any question. Okay, so after this, then we are going to move on to the last part, which is Kruskal algorithm. Okay, so Kruskal algorithm will be quite straightforward. It's actually quite a short part compared to Prim's algorithm. Kruskal algorithm is a method of choosing the edges. Okay, so what do you need to do is you will start from the edge with the minimum weight. Then after that, you keep on choosing the edge with the next minimum weight. Then you need to repeat until those vertices, until all the vertices are included, and make sure there's no cycle as well. Okay, for Kruskal will be quite straightforward, but the only thing is you are thinking about next shortest edges. So you don't need to look at vertices, but the edges this time. Okay, so for example, step 1, choose the edge with the minimum weight. So you need to look at every edges in the graph. Okay, so let's say the 7 is the minimum, right? So that's why we are going to pick the 7. If let's say there's more than one edge that give you the lowest value, then you just take any. So for example, let's go with GI first. Okay, so as we have already highlighted GI, then the same thing, step 2, just now we already picked GI, right? Okay, so GI is 7. The next shortest one is still going to be 7 as well. So let's say I take BC. So it doesn't matter whether you want to go BC or DF1. Okay, so same thing, we move on to step 3. Okay, so we are going to do the same thing as well. So just now we have already picked GI and also BC. Okay, then the next one, the next shortest is going to be still 7, which is DF. Okay, so after we have completed with this, then the same thing. So just now we already covered the 3 edges. Okay, then after that, we will just repeat the entire thing for this diagram because it's quite straightforward. Okay, so after 7, then the next shortest should be 8, right? So that's why we have 8 here. So you want to go DE first also can, go FG first also can. So if let's say we go DE first. Okay, so as we go for DE, then the next shortest one will be 8 as well. So just make sure that when you highlight, you don't create any cycle, then it should be fine. Then after that 8, then the next one will be 8 as well. So after 8, the next smallest number is 9, right? And if I highlight this, then I didn't create any cycle, so that's why I can highlight this. So after 9, the next shortest is 10. So if I draw this, I will create a cycle. If I draw this, I create a cycle here. If I draw this, I create a cycle here. So that's why I'm not going to take any 10. And after 10, the next shortest is 11. So that's why we take 11. After 11, the next shortest is 12. But then for 12, we are going to create a cycle here. So that's why we are not going to take 12. Same thing, if we take 12 here, it will create a cycle here as well. Then the next shortest one will be 16. And if you highlight 16, it wouldn't be any cycle, right? So that's why we can highlight 16. Okay, so that's why now you will realize that all the vertices, they are already connected and then there's no cycle. So that's why same thing as well. 1, 2, 3, 4, 5, 6, 7, 8. So you got 8 edges when you are having 9 vertices. So you know that the answer is correct. Okay, so this is actually the same example that we have used just now. So you realize that for the answer that you get here, right, is exactly the same answer that you get over here. So it's exactly the same thing, regardless what algorithm that you are using. And you realize that no matter you are using Prims or you are using Kruskal, right, actually your working at the end of the day will look like the same. So that's why in the exams, the people wouldn't be able to know like which one that you are actually using. So it will be just up to you, like which preference, which one you prefer more. I mean, for me, in terms of diagram, I feel like Kruskal is easier. Okay, but then like what I say, it's important for you to understand how Prim's algorithm works, because later we are going to talk about the distance table, and for that situation you can only use Prim's algorithm. Okay, so when you add up all the number, then you should be able to get 73 km as well. Okay, so just a short notes before we move on to the last 2 exercises again. Okay, so you will realize that you will be able to get the same solution no matter you are using which algorithm. So for a graph with lesser edges, actually Kruskal algorithm is easier. For less edges, which mean like the situation that we are looking at for now. Okay, so this is considered still quite, I mean, the edges is not like a lot. But in a dense graph, for example, you realize that if let's say you try to imagine if let's say you got 1,000 vertices, or maybe let's say not 1,000, maybe you got 100 vertices, then inside then you have, you can imagine if let's say you got 100 vertices, then you will be having a lot of edges as well. So if let's say you got a lot of edges, like let's say 200 edges, then if you want to look at all the 200 edges to find out the shortest and the next shortest and the next shortest, it will be very difficult. So that's why for a graph that having a lot of vertices and a lot of edges, and that's why Prim's algorithm is easier, because you can choose anywhere to start. Then you just need to look at the neighbor, then you slowly extend to a bigger area, instead of like you need to look at the entire graph to find out what is the shortest. Okay, so yeah, because it might be challenging when you want to compare a huge amount of edges and to choose the shortest one. Okay, and then Prim's algorithm, one of the important thing about Prim's algorithm is that it will allow us to find out the minimum spanning tree when the weights are displayed in the form of distance table. Okay, which is what we will cover in the next lesson, which we talk about minimum spanning tree in terms of a distance table. Okay, so the last thing, same thing. So pause the video, then I want you to try to use Kruskal algorithm, and then you try out for these two examples. All right, so same thing, very quickly, we go through the answer. Okay, so among all the edges that you're having here, the shortest will be 180. So 180, 180, 180, 180. Then the next one, we have 190. So make sure that when you are choosing it, make sure you don't create any cycle, okay? So 190, then the next one is 200. So after 200, then you have 200. Okay, 200 here will create a cycle, so we are not going to choose that. Then the next one, we have 270. Okay, so you can realize that this part of the graph, they are all connected already, and no matter which one that you are choosing, you are going to create a cycle. So as the next part that you only need to think about it is how to make this connected to the entire part of graph. So 400, 350, and 390, then definitely 350 lah. Okay, so that's why you should be able to get the exact answer that you get by using Prim's algorithm. All right, okay, so the same thing for the next part. Okay, 7 first. Then we have 8 here, 8 here. Okay, then 9, 9. Then next one only 10, 10. And then 11. Okay, so now, yeah, you realize that all the vertices, they are already connected. So that's why this will be the answer. And you realize that it's the same with whatever that you got just now. Okay, so make sure that you try to understand this, as it's actually quite easy. So you shouldn't be losing the mark when it's coming out in, tests or exams. Okay, so do make sure that you understand how to do it. And if you got any question, feel free to just text me through Teams. Okay, so yeah, thanks for watching it, and remember to do your homework. All right, thanks everyone.